Now in this video we'll talk about spanning tree, uplink fast and backbone fast features. Now these are typical legacy methods, no more used, but there are some enhancements done by the Cisco to speed up the convergence time. Like one was the port fast port. Now port fast is something done on the access ports, where whichever the port is enabled with the port fast, it will bypass the listening and learning stages and transitions immediately into forwarding without listening, without learning. Now apart from that, Cisco also added some of the other enhancements, like in that one of the other one is uplink fast here. Now in case of uplink fast feature, now if you just take an example here, in my scenario there are two, assume that there is a switch ABC and there is a blocking port here. Now as per the default spanning tree will put the alternate port into blocking state. Now this is my alternate port, and then there are two types of links here we need to understand. And there is one link here, this is my direct link. Now we call this as direct link. Direct link is the link which is on the same switch as a blocking port. Now this link, if this link goes down, due to some reason, let's say this link is down, by default the spanning tree is going to converge in 30 seconds. That's the default convergence time if the direct link fails. Now whereas there is one more link called L1 here, this is my indirect link. Now the indirect link is the one which is on a different switch when compared with the blocking port. Now the blocking port is on the switch C and your direct link is on either on the switch A or switch B on the opposite side. So we call these two links as indirect link and the direct link based on the way they are on the, whether they are on the same switch or a different switch. If your blocking port and the main link, if it is on the same switch, we call them as direct link, and if the blocking port and the main link is on a different switch, we call it as indirect links. Now let's try to understand the default spanning tree convergence. As per the normal spanning tree convergence here, if your direct link fails, now if this direct link fails, by default it goes through listening state for the 15 seconds and goes to learning state for the next 15 seconds before it actually transitions into forwarding. Now which means this blocking port comes to forwarding after 30 seconds in case if your direct link fails, in case if your direct link goes down. Whereas in case if your indirect link fails, let's say if this indirect link fails, in that kind of scenarios it's going to take around 50 seconds of default convergence time. So let's say if my indirect link fails, indirect link goes down, in that case it's going to it will remain in the blocking state for the next 20 seconds expecting a BPD message from the root bridge, but this side there is no BPD messages and it is going to wait for the maximum of 20 seconds, and then the port goes into listening state and then learning state, and after 15 seconds it will take around 50 seconds for the default convergence time. So if you want to verify, we can still verify this default behavior by connecting some of the switches here. Now this is the default convergence time. Now the Cisco has added some enhancement to this default convergence. Now we can verify this default behavior of the spanning tree by adding some default connection here. So if you just try to observe here, in this scenario there is one port. So let us try to understand who is the root bridge here. In my scenario there are some three switches, switch 3, 4 and 5. This is my switch 3, switch 4 and switch 5. And in this scenario this port is a blocking port, and then as per the default STP calculation, this bridge is a root bridge. I can see the message, this bridge is a root. So if you want to specifically change the root bridges, we can even change, but the default parameters, now this is a root bridge. Now there are two types of links here. We have something called direct link. So I'll try to shut down this link and we'll try to verify the default convergence time on port number 21 on the right side. So let's go to switch. On the switch 3 command line here, I got a show spanning tree here. When I say show spanning tree, port number 21 is in the blocking state. I'm going to shut down the port number 20, and then once I shut down port number 20, if I give show spanning tree, I can see the port immediately transitions into listening state, and after some time it will go to learning state and then back to forwarding state. So let's give some time for the convergence. So listening, learning and forwarding. Now this is a default timer it's going to take. If any direct link fails, the alternate port immediately transitions into forwarding after 30 seconds. it will not go through with the block, the 20 seconds hold on time. It's not going to wait for the time. Now the same thing, if I verify the same thing, let me make the interface back to up. If you want to verify, you can try to shut down this link, any one of this link, it will transitions into forwarding. Now this particular port will transitions into forwarding after 50 seconds of time. Now this is the default convergence time which spanning tree is going to use, and Cisco added some enhancements to this default spanning tree here. Now the first enhancement was uplink fast. Now in case of uplink fast feature, if your direct link fails due to some reason, if the direct link fails, the alternate port transitions into forwarding immediately in the next second, we can say immediately, without waiting for the listening and the learning stages. So it transitions immediately into forwarding in the next second. And whereas Cisco added one more enhancement to this particular spanning tree behavior called backbone fast feature. Now if I enable backbone fast feature in those kind of scenarios, what it is going to do is, if any indirect link fails, it's going to send some notification message to the remaining switches about the link status, and based on that notification message, that the device do not need to wait for the default downtime, that is the hold down time, and then it can immediately transitions into listening and learning stages, which means it's going to take somewhere around 30 seconds of time rather than using the default timer of 50 seconds. Now the indirect link fails, the alternate port comes to forwarding, around 30 seconds of time. Now these are the Cisco proprietary enhancements to speed up the convergence time, but in today's networks we don't use these two enhancements because the IEEE has come up with something called rapid spanning tree protocol, and if you enable rapid spanning tree, it's going to allow. Now there is something called rapid spanning tree protocol, and if you're using rapid spanning tree protocol, it comes by default with a port fast feature and along with the uplink fast feature, and then it also includes some backbone fast feature automatically. So we just need to change our normal spanning tree to rapid spanning tree protocol, and which has the default uplink fast feature inbuilt in that, and then the backbone fast, but the timer is different. It's not going to take 30 seconds, it's going to immediately transitions into forwarding without much delay. Now that's make these two features are not really used in today's production network scenarios, and maybe the new IOS, they don't support the exact command lines. So if you want to enable the spanning tree uplink fast, we just need to enable on the switch. It's going to enable for all the ports. Now we can verify somewhere here. Once you enable uplink fast, when you use show spanning tree, you can verify here, and this command is not allowed on the root bridges again. And then, because normally the root bridges will not have any alternate ports generally. And then the spanning tree backbone feature, and to enable the backbone fast, we just need to go to the config mode, and then we can enable by using a command called spanning tree backbone fast, and you can verify it with a show spanning tree backbone fast. Now these are the specific command line which we for configuring these features. But if you are enabling with rapid spanning tree protocol, now this rapid spanning tree protocol by default comes with the uplink fast and the backbone fast features, which is providing a rapid faster convergence than a normal spanning tree behavior. So we'll be talking about more on the spanning tree convergence, how it's going to work, the default synchronization process, more in detail in our next sections.